everybody. In this video, I'm going to show you some of the uses that factored form of a quadratic function has. So, if we want to graph this quadratic, the most direct route to graphing a quadratic most of the time is to convert to vertex form, which we could do. Now, I'm going to start doing this, and I think you'll see we may end up getting frustrated and want to stop. So if I wanted to convert this to vertex form, now see my video on converting to vertex form if you haven't done that yet. But what we'd have to do first is multiply everything out to get standard form. So I need to multiply x times x is x squared, and then let's see, I have negative 6x and a positive 2x, so that's minus 4x, and then negative 6 times 2 is negative 12. Now I have to distribute the 1/8 to finish getting standard form, so that would be 1/8 x squared, and 1/8 times 4 is a half, so that'd be minus 1/2 x, and then 12 times 1/8 is, let's see, if we simplify, that'd be 3/2. So minus 3/2, since both 12 and 8 are divisible by 4. Now, I'm already not liking this. There are a whole bunch of fractions here. I suppose we can keep going, but this is already kind of frustrating. But anyway, to recap my video on converting to vertex form, you take the leading coefficient, which happens to be a fraction in this case, and you factor that out of the first two terms only. So we're not backtracking to the first step. We're only factoring the negative 1/2, or sorry, we're only factoring the 1/8 out of these first two terms. So 1/8 divided by 1/8, that's x squared. That's kind of the whole idea. And then negative 1/2 divided by 1/8. Well, if you divide by 1/8, that means you multiply by 8, and 8/2 is 4, so that's minus 4x. Leave a space for completing the square, and we move the 3/2 over. Now, in that blank space, we're looking for one very particular number. Whatever this number is, the coefficient of the linear term, you take half of that and then square it. So half of 4 is 2, and 2 squared is 4. So we put a plus 4 right here. Now we have to balance that out. Very common mistake. I don't balance this out with a minus 4 because that's not really a 4. If you imagine using the distributive property, 1/8 times 4, well, 1/8 times 4 is a half, so we balance out a half with a minus half. And then we have vertex form. It wasn't a whole lot of fun because fractions were involved, but we did get there, I suppose. This trinomial factors into a perfect square. That's the whole idea of completing the square. And then negative 3/2 minus 1/2. The denominators are already the same, so that'd be negative 4/2, which is negative 2. And there you go, vertex form. Assuming that we did that right, then we'll be able to graph this quadratic. We'll put the vertex in place at, let's see, let me write it out. If you didn't watch my prior video on graphing quadratics in vertex form, please do so. The vertex of this parabola, again, assuming we've done this right, is at 2, -2. And the trick from that prior video, I'll write yet again, the parent function parabola, the really basic parabola, y equals x squared, if you count from the vertex, goes over 1 up 1, over 2 up 4, over 3 up 9. I'm actually going to do one more. You'll see why in a moment. Over 4 up 16. So if we wanted to graph, we put the vertex in place at 2, -2, and we have to count. But now realize this is on Khan Academy. We just need to put one more point in place. So I'm going to look at the number in front. That's an 1/8. Let me switch colors again. If we take that number 1/8 from the prior video on graphing from vertex form, you know that we multiply these numbers by an 1/8. Now the reason I went all the way to over 4 up 16 is I was kind of thinking ahead. I knew I was going to need to multiply by an 1/8 and 16 is divisible by 8. So from the vertex, we're going to go over 4 up 2. And so, let's see, from the vertex we go 1, 2, 3, 4, 1, 2. And there you go. That is the graph. Now, you may be thinking to yourself, I hope you're thinking, well, that was a lot of work just to graph a silly parabola. Graphing parabolas is supposed to be fast. Well, we never actually used the fact that we had factored form here. So pretend that none of the work on the left side of the screen was there. So pretend we didn't do any of that at all. So the thing that factored form is useful for is just by looking at it, you can see where the x-intercepts are. Now, if you're doing this yourself, you don't even have to write out any work. I will, because I'm making a YouTube video on this. But to find the x-intercepts of any function ever, you set the function equal to 0. You make y equal 0 because the x-intercepts, those are on the x-axis where y equals 0. So we have x minus 6, x plus 2, and we're going to replace y with 0. Now, since this equation is already factored, that means, well, the work is already done. If we're already factored, you set each factor equal to 0. And then you solve these two equations. So you might think to yourself, well, we're done. We have the two x-intercepts. Let's just put those in place. Now notice we actually already ran across one from the previous work on the left. So x equals 6, that's one of our x-intercepts. And you might think, well, let's just drag this other dot over to the other x-intercept, and Khan Academy fooled us. The easiest way to connect the two x-intercepts is with a straight line, so that's not going to work. So we are going to need another interesting point. So the easiest way to do that is to find the vertex. So you might be thinking to yourself, well, that just means we're going to have to do all this work over to the left anyway. But no, there's actually a shortcut. If you'll remember, parabolas are symmetric around a vertical line that goes up and down through the vertex. And notice these 2 points, well, they're on the same horizontal line, so the vertex has to be halfway between these two x-intercepts. So a really quick trick for finding the vertex is as follows. So what we're going to do, and again, if you're doing this yourself, it's not like you have to write out all of this. You can pretty much do it in your head. What we're going to do is we're going to find the x value of the vertex, and the way we're going to do that is we're going to average the x-intercepts. Now we already have the x-intercepts, and you could probably just do that in your head by looking at factored form. I can see that they're at 6 and -2, but let's average those. 6 minus 2 over 2, that's how you average numbers. That's 4 over 2, and that's 2. So the x value of the vertex is at 2. So the axis of symmetry is this line. And now if I want the y value of the vertex, well, all I have to do is plug in x equals 2. And that's going to give us the y value of the vertex. So we do y equals 1/8 times 2 minus 6 times 2 plus 2. So that would be 1/8. 2 minus 6 is -4. And 2 plus 2 is +4. So -4 times +4 is -16. And -16 times an 8th is -2. Now we knew that was the answer because I never erased the work that's on the left. But realize, well, now we're done. And see how quick this was. Remember, I'm making a YouTube video. I need to write this down so you guys can see it. But if you were doing this yourself and you know how to work with factored form, the logic would be really quick. You'd look at the factors and say, hey, I know the intercepts are at 6 and -2. You average those to get the x value of the vertex, And then the only thing that you might have to write down, depending on how comfortable you are with mental math, is plugging in x equals 2. This is significantly easier than converting to vertex form. So factored form is really nice. It gives you the x-intercepts quickly, and it allows you to find the vertex without a whole lot of work. Anyway, that's what factored form is good for. Hope this video helped.